These are the last problems out of homework set 36. Question 16, let's solve this logarithmic equation for x. So the logarithm is the exponent. That exponent, x, is going to go on that base. 9 to the x equals 81. And just by our knowledge, we're going to say that x is equal to 2, right? 9 squared is 81. Now, in question 17, we're just supposed to simplify, right? We're not solving anything. Just simplify it. Now, this is the logarithm base 64 of 8. What is this equal to? Well, right now, I don't know. So what I might just say is this. The logarithm of 64 of 8 is, I don't know what it is, so I'll write an x. That tells me that 64 to the x is equal to 8. Now, what do you know about the relationship between 64 and some number to get you back to 8? Now, 64 is bigger than 8, so I got to bring it down to 8. So I do know this. What if I took the square root of 64? That's equal to 8. But the square root, that is, the 1/2 exponent. So what if I wrote 64 to the 1/2? That's equal to 8. So what I'm looking for here is 1/2. So what I'm saying is that this number here, log base 64 of 8, is really just a half. Can we simplify this one here in 18? The log base 4 of 64? Well, it's some number, right? It's some number. So right now, why don't we just call that number x? So let's say this is equal to x. That says, when I translate it to something more familiar, like exponential form, 4 to the x, right? The logarithm is the exponent. 4 to the x is 64. Now, what power did you raise 4 to get 64? It's not 1. It's not 2. 2 squared is 16. It's not, is it 3? It is 3. All right, so x is equal to 3. So then I would claim, now the answer is not x equals 3. This expression right here reduces to 3. Question 19, we've got this graph. And what we're asked for is, what form is this? Is it exponential form or is it logarithmic form? Well, exponential form, I know, looks like this. Exponentials go like this. Logarithms go like this. So I'm going to claim it's this one right here. So let's mark that one. Now the second part here is, what is the value of b? Now our equation looks like this. It is y equals log base b of x. And we're trying to find out what is b equal to. The best way to look at this is to look at the graph and see where it crosses at a coordinate point. Right now, I'm looking at this graph. It crosses here at 1, but keep going. You see up here, it looks to me like it gets to 1. What's the value when this is 1? It's at 5. Second part of the question down here is, what is b? All right, here's our equation is this. Y equals log base b to the x. All right, so I just need some general knowledge here about logarithms, and here's the one that we're going to use. We know that the logarithm of any base of 1 is 0. So convert it. This says that b to the 0 is equal to 1. All right, so what base am I going to put here to the 0 power equals 1? All right, so look up here to the graph. Now, when is this thing equal to 1? So if I look to 1, it's going to be 1 right here. So what's going to give me a 1? Well, it has to be something to the 0 power. And the only thing that's going to work there is the 5. So I'll just follow it down, and then I'm going to claim that b is equal to 5. Because 5 to the 0 is equal to 1, and this would say, convert it back, logarithms are exponents. The exponent is 0. That's equal to the logarithm. There's the base of 1. And sure enough, if I look at the graph, question 20, which one of these functions, exponential or logarithm, is this graph? Well, I'm going to claim it is the log function. Here in question 21, we're asked, which form is this graph? Is this an exponential form or a log form? Well, this looks to me like an exponential decay function. So I'm going to claim that this is this form right here. Now I know this, x is the horizontal axis. If I put in 0, then this result is a 1. So let me put those numbers in here. So 1 is equal to b to the 0. Now, follow this over as best you can. If you were right here, following that over, you know what I'm going to do just for a minute here? I'm going to make this really big. So if I follow this over, locate x equals 1 and follow it over, what do you think you get? This is pretty difficult. You really have to make a good guess. It looks to me like it could be 1/4. I'm going to put 1/4. So I'm going to claim here that b is equal to 1/4. Or actually the answer would just be 1/4. 22. We're going to use this formula here. M equals log base 10 of t to find the magnitude. So m is the magnitude of an earthquake that has a shock wave of this size here, t. So this is the size of the shock wave. This is the magnitude of the earthquake. So let's put the numbers that we know in here. So I'll just rewrite the equation. M equals log base 10 of t. Now here's what we know. T is 1,000. All right, so m is equal to the log base 10 of 1,000. Now keep in mind, logarithms are exponents. So the exponent here is m. It goes on that base. So let's convert it to 10 to m, some power, is equal to 1,000. Okay, now just from your general knowledge, what does m have to be? It can't be 1. That's only 10. It can't be 2. That's 10 squared. That's 100. What about 3? 3 works. Magnitude 3. This would be a magnitude earthquake. And what this says is that if the ground is shaking 1,000 times the minimum value, then you get a size 3 earthquake. Let's simplify this one. Look at these log. I got a log of a log of a log. I'm going to start here with this one. So just rewrite what you've got. Just bring it all down. Log base 5 of the log base 3 of, now we can get this. What power are you going to raise 3 to get 27? Right? Logarithm is an exponent. So you're looking at an exponent here. Doesn't look like an exponent, but it's an exponent. So what exponent would you put on that 3 to get to 27? 3 times 3 times 3 is 27. So this is going to be a 3. Now, what is this one here? Well, it's an exponent. That's an exponent. Logarithm is an exponent. What exponent are you going to put on that base to get 3? Well, 3 to the 1 is 3, so this is just a 1. So now I've got the log base 5 of 1, and the log of 1 to any power is 0. 24, we've got another earthquake problem again here. It says, use this formula that we've seen before to find the magnitude of an earthquake with a shock wave of, this time it's 1,000,000. Last time it was 1,000. So now I'm going to rewrite the equation here. M is equal to log base 10 of t, and I know that t is 1,000,000, so I'll have 1,000,000. Oh, m is equal to the log base 10 of 1,000,000. So log base 10 of 1,000,000, it's equal to some number, all right? It happens to be equal to that number m, right? The logarithm is the exponent, all right? So I'm going to have that m is the exponent. That's going to go on the base. 10 to the m is equal to 1,000,000. All right, so what would you put for, what power are you going to raise 10 to get to 1,000,000? It's 6. So this would be a magnitude 6 earthquake. Last question in this set. let's simplify this. Log base 3 of the log base 5 of 125. Now I'm going to start with this one right here. So what power should we raise 5 to get 125? Well, it's not 1, it's not 2, 5 to the 2 is just 25, but it is 3. 5 times 5 times 5 is 125. So now I've got the log base 3 of 3, and when the base and the argument match, you just get a 1. Right? What power would you raise 3 to? 3 to what power is going to give you 3? I'm thinking this. 3 to what power is going to give me 3? Well, that has to be a 1. All right, so I'm going to say that this whole thing here is equal to 1. And that finishes up homework set 36.